Okay, so the second question on geometry on the 2019 paper 2 was this one, question 7. A triangle has one side of length 10 and another side of length x. The perimeter of this triangle is 26 centimeters in length. Find the length of the third side in each case in the table below. So diagram A, I have a side 4, side 10, and the perimeter is 26. So perimeter is what I say walk the walk. So literally walk around all of the edges and you get to, in this case, 26, okay? So what I would do is I would go 4 plus 10 is 14 centimeters. 26 minus that 14 centimeters is 12. Okay, in this one, perimeter is again 26. Okay, so let's walk the walk. We have 9 and 10 and the third side in this case. So 9 and 10 is 19. 26 minus that 19 is what? 7 centimeters. Okay, so part A was okay. Part B, find the three values of x that makes the triangle an isosceles triangle. Okay, so I'm a bit confused by the three values of x, okay, because I just see two values. But anyway, not to worry. I'm going to draw out two triangles. I'm going to draw out that first one there, okay? So what it's telling me is that this side is 10, okay? So when I read up here, a triangle has one side of length 10 and another side of length x. Okay, oh, and it's an isosceles triangle. So I'm going to change my triangle then, because in an isosceles triangle, two sides are equal in length, okay? So let's try and make it at least look somewhat equal. So one side is 10, and I need to work out the other two sides. Okay, so how do I do that? The perimeter is still 26. Okay, so 26 minus the 10 is 16. Okay, and in an isosceles triangle, two sides are equal. So couldn't I say 8 and 8 for that one? Okay. So one case is where two sides are 8 and 8 and the other side is 10, and that's an isosceles triangle. Okay, now where does the other one come out of? Okay, well, let me draw a different triangle. In this case, again, isosceles. Okay, now remember it said one side was 10 and the other was side x, okay? Well, isn't there a case where he could be 10 and he could be 10? Okay, so there's nothing stopping another side being 10 because that would also be an isosceles triangle. Okay, so in this case, I have 10 and 10 is 20. 26 minus that 20 gives me the other side being 6. Okay, so both of them are isosceles triangles, one with side length 10, all with perimeter 26. Now this is where I get a bit confused because I'm not quite sure what they want me to put into the box up here. I think they want 8 and 8 here because both of them are side x, and then 6 down in the last one. Okay. So all of the answers that I found that weren't 10 is what I think they found. I'm not really too worried because my picture is here and my calculations give the answer anyway, okay? It's just trying to understand how they want you to give their answer. So don't worry about that stuff. Do your maths, give them back the answer. Okay, part C. The graph below shows the area of the triangle for all values of x between 3 and 13. The point A is marked. Okay, so when I'm looking at a graph for the first time, the first thing I do is look at what's on the y-axis. So that's area of triangles. I'm looking at what's on the x-axis, and that's x in centimeters, which I presume are Yeah, I'm not quite sure. But anyway, so of area of triangles. A is the point on the graph where x is 4, okay? So if we go up from 4, which I presume is one of the sides of the triangle, and I go across, I get the area of that triangle. Okay, so A is the point on the graph with x equal to 4. So it represents the triangle in diagram A. Okay, so x is equal to 4 is indeed one of the sides of the triangle. Okay, use the point A on the graph to estimate the area of the triangle in diagram A. Okay, so what you do is you dot across with your ruler to get the area of that triangle, okay? Because that's what it said here. And you take down that value. So that's 15, 16, 17, 18. So I'd say I'm not quite at 18 or at 19. Let's go 18.8 centimeters squared or something like that, okay? I'm not quite at 19. I'd say if I removed my line here, I'm not quite at 19. Okay. And you'll note it's also really important the word estimate, okay? So everybody's going to get slightly different. So the answers in your exam would be like a range. It could be accept answers from 18 point, it could be anything, 18.7 up to 18.9 or something like that. Okay, plot the point B on the graph to represent the triangle in diagram B. Okay. So I have 9, 10. See, oh, do you know what? I'll just copy it. I was going to try and draw it. With my fabulous drawing skills, I might just copy it. Okay, so label the point B on the diagram to represent the triangle in diagram B. Label the point. So what I have to do, because this is showing area of triangle, is I have to get the area of the triangle, and whatever that area is, come across until I hit my curve. Okay, so we know that one of the sides is 9. We know one of the sides is 10. Okay, so I'm either going to come up here and go across. That's one way of doing it. Or come across here. Okay, so slight differences between which one I take. Okay, so show you now what I'm doing. Okay, so area of a triangle is half the base by the perpendicular height. Okay, so half of, I say 7 by 9, okay, because they look perpendicular to each other, is, and 7s are 63 divided by 2, 31.5. Okay, so 31.5 is a little bit up there. So let me come across 31.5 as best you can. And you can see that you're going to hit off it at 9. Okay. So that is the point B. So I hope that makes sense. If I had gotten an answer less than 30, I would have come across at 10. Okay, so that was part 2. The graph is symmetrical. Draw the axis of symmetry of the graph on the diagram below. Write down the equation of the axis of symmetry. Okay, so symmetry means I can literally fold it in half, and one side will fold directly onto the other. Okay, so for example, if I consider this rectangle here, I could draw an axis of symmetry down here. You're going to have to imagine that's in the middle now because I'm not going to get it right. And this line that I draw is your fold line. So can you see now this half folded over onto this half? Okay, so that line there is your axis of symmetry. Now, of course, a triangle has more than one, or sorry, a rectangle has more than one axis of symmetry, because isn't there one that way as well? Okay, where again I can fold the bottom onto the top and it'll be a perfect replica of each other. A rectangle doesn't have a diagonal symmetry line. It doesn't work. And to prove that to yourself, get an A4 sheet of anything out of a refill pad or a photocopy sheet and try folding that on the diagonal, and you'll see that it doesn't have lines of symmetry in the diagonals. Okay, however, a square does. A square would have diagonal lines of symmetry. So play with the piece of paper and the shapes and just, I suppose, become familiar with lines of symmetry. So where is the line of symmetry in this? Where can I put the line so that one side folds onto the other? Well, I can't do it across there because you can see this is wider than up here, but I can do one down the middle. Okay, so to work it out, I would do 13 minus 3 is 10. Divide that by 5. Okay, or sorry, divide that by 2, which is halfway, and I get 5. So let's come up 5 units from 3. So 3, 4, 1, 2, 3, 4, 5. Okay, so you can see mathematically and visually my line of symmetry occurs down here. Okay, so to answer this one, so the green line equals axis of symmetry. Okay, and then the equation of this line. So any line that comes directly up from the x-axis, the equation is x equals. So in this case, x is equal to 8. Okay, so what that means is it doesn't matter where you are along this line. Yes, your y value is changing, your y coordinate. If you think about coordinate geometry, your y value is changing, but your x is never changing. Your x value is always 8. So the equation of that line is x is equal to 8. Part D, this was a long question. When x is equal to 5, the triangle has sides 10, 5, and 11. Show that this is not a right-angled triangle. Okay, excuse my drawing. Okay, so it doesn't even look close. Okay, so a side 11, a side 10, and kind of a smaller side 5. So I don't know how you're going to do that one. 5, 11, 10, for example. Okay, so when x is 5, the triangle has sides 10, 5, and 11. Show that this is not a right-angled triangle, okay? So the easiest way of showing something is right-angled is using Pythagoras Theorem, okay? So we would have done this in trig, okay? So remember Pythagoras Theorem, c squared is equal to a squared plus b squared, okay? Where c is your hypotenuse and a and b are the other two sides, and it doesn't matter which is opposite and which is adjacent, okay? So how do I know which one could potentially be the hypotenuse in a triangle? Well, the hypotenuse is always the longest side, okay? So hypotenuse is always the longest side, okay? So this one could potentially be the hypotenuse. And I'm putting a question mark there because you only have a hypotenuse on a right-angled triangle, okay? So we're showing this is not a right-angled. So that's probably not the hypotenuse, okay? And it doesn't matter which one I call opposite and adjacent in Pythagoras Theorem. So is this true? Basically, that's what I'm checking. Does Pythagoras Theorem hold true? In other words, is c squared equal to a squared plus b squared? If it is, it's a right-angled triangle, okay? If it's not, then c squared will not be equal to a squared plus b squared, okay? So let's check it. So is 11 squared equal to 10 squared plus 5 squared? Okay, 11 squared, 121, 10 squared, 100. So 121 is not equal to 125, okay? Therefore, not a right-angled, and again, I'm giving them back their words, not a right-angled triangle, as Pythagors Pythagoras theorem does not hold true or is not true. Okay, so that's how you check if it's a right-angled triangle. Okay, so part E, the diagram shows below the triangle with the biggest area. Work out the area of this triangle. Okay, part E. Okay, so do you remember in the last one when I was doing the area, when I was plotting it here, I did half the base by the perpendicular height, okay? Now half the base by the perpendicular height, I suppose what I'm trying to say with that is you have to have a perpendicular height. So when I look at this triangle, it doesn't have a perpendicular height yet, okay? This is called a slant height. This is a slant height. Okay, and this I suppose is your base. So where would I draw a line that's perpendicular to that one? Okay, well, I have to draw a line that's literally straight up. Okay, so all of those green lines I just drew there are perpendicular to the bottom. Okay, they're straight up. So you can see now that's why they're called slant heights, okay, because they're slanty from the bottom. They're not straight up. Okay. So a couple of things. This is an isosceles triangle. Okay. In other words, the two sides are equal. Okay. So in this type of triangle, can you see that it has an axis of symmetry? Okay. So I could draw a line. No, sorry, directly down from the top as such. And isn't that a perfect axis of symmetry and in an isosceles triangle? Okay, it wouldn't work in a scaling triangle, it'll only work in an isosceles triangle. And now can't I fold one side over on the other? Okay, and what you'll see in this one is he will be 5 centimeters and he will be 5 centimeters. Okay, so how do I work out the area of the triangle then? Okay. Well, I think you need to work out this side here, the perpendicular height side. Okay. So how do I do that? Well, let's take the right angle triangle. Fill in what we know and work out this side. So how would we do that? Well, when you draw a line perpendicular to another, like we've done here, you automatically get a right angle triangle. Okay, so again, I'm going to use Pythagoras theorem to find out this side x. Okay, so remember, c squared is equal to a squared plus b squared. Remember, c has to be my hypotenuse, so I cannot put x there. I have to put 8. Sorry, I have a tickle in my throat. Okay, so 8 8s, 64 is equal to 27 plus x squared. Bring him over so that you get 64 minus 25 equal to x squared. Popping onto my calculator, 64 minus 25 is 39. So therefore, the square root of 39 is equal to x. Okay, and I'm not going to change it to a decimal because I can see here that they want surds in my answer. Okay, so s to d square root of 39. So it is 6.25 or thereabouts, 244. Okay, so it is 6. Okay, and that's what I would expect. Remember I said hypotenuse is always the longest side in a triangle, okay? So I was expecting that to be less than 8, okay? So that feels right. Okay, so area then is half the base by the perpendicular height. Okay, so it's half of that 10 on the bottom. Okay, because now I can take the full triangle because that side I just worked out is this perpendicular height in the triangle. Okay, half of 10 by root 39. I'm going to put that into calculator. Half of 10 is 5 root 39. Okay, so that is the area of that triangle. My units centimeters squared because it is indeed area, so it's squared. Okay, so that question was quite difficult because it mixed so many chapters together. It mixed area and volume together. It mixed a geometry where you're looking at your triangles. Mixed a little bit of kind of a functions question. And then, of course, went into trig, Pythagoras' theorem, and finished again with an area and volume. So a real mix of chapters in that one. So it was quite a difficult question on the 2019 paper.